Hi friends, in this presentation we are going to be considering the modeling, analysis and design of these commercial uh, park stations, car park stations. Okay, this is a commercial car park stations, so we will be modeling this, we'll be analyzing, and as well we will design each of the structural members successfully. All right, you are welcome once again. This is CAD level. Before we go into the lesson properly, I will advise that you like this lesson. I will also advise that you subscribe to this channel, as I will be bringing to you an advanced lesson of this kind. Okay, so right away, let us go into the lesson. I will have to create a new project. I'll click on the new right away, and then I'll give it as anger 3. Okay, so just to change it to 3, click on OK. I will import BS Eurocode, UK Eurocode, import that successfully. This is after successful importations of that code. I will be setting out the grid lines. Click on the orthogonal exit generator. I will have to click on its provisions. This point. Alright, so in the direction 2 axis, I will be having a spacing of 6 meter. Alright, spacing of 6 meter, just like this. Spacing of 6 meter. And then it's going to be times 3 provisions. Alright, so in the direction 1, I will be having a span of 4,800. All right, I am trying to consider the length of purlins. All right, and in these provisions I'll be having it multiplied by 8, so I'll be having 8 provisions. So this is the settings. This is the settings for that commercial park car park stations. Click on the OK options to have the grid set out just like this. All right, the next thing we're going to be considering is we're going to set our stories. We'll be having only 2 stories in this design. Alright, so we have to navigate to the stories, right click and then insert stories. And the second story, we have the first story existing right away. Second story, we impute it as 2. Click on the OK yes options. Alright, so we have to edit story now. So select the story, right click on the edit story. In this provision, this story, we are going to be having it as a 500. The steel stanchion is going to be resting on these stories, so it is 600 from the ground level. Okay, so we impute 600, 500 right there. Okay, so this the height of the hanger is going to be 3 meter for the sake of this lesson. All right, and then the foundation layout is going to be 900, just like this. Okay, so after which this is the necessary set out. Click on the OK options. After which you navigate to the story 1. At the story 1, we'll start to place our reinforced concrete vertical members. Okay, so you select the columns right away. Alright, so in the column dialog, we'll be having a column sections of 350 by 350 square sections. Alright, just like this, 350. Alright, so after which we just have to insert it. I want to click right here. I click right, I do a sheet over all of these provisions, and I release my hand to insert the columns just like this. Okay, after which what I will need to do is we are going to be having this this grid line 2. We'll be having extensions on this grid line 2. We have also be having extensions on this grid line 3 successfully. So just have to close this right away. So you navigate to the story 2, and the story 2 we will start to insert the stanchion. So just click on the steel columns right there. Then in the provisions section manager, select that. I will be using universal columns section 203 like this. I'll click on select, and then I will click on OK options. Okay, so once you select the OK options, you start to insert your steel stanchion. But the orientations, I don't like it. I want to change the orientation, so I'll go back to the section manager and then rotate it these directions. Click on OK. Now I like this orientation of the column now, and then I will pick it here, hold down the left mouse button, and then do a sheet over the provisions you needed to insert the columns of the grid lines intersections. Release your hand just like this to have it inserted successfully, just like this. Okay, alright, so after which we are going to be inserting the steel beam, the beam, right, the steel beam. So we navigate to the 3D. So this is what we have. Okay, but before we insert this steel beam, we will be having a beams. Okay, beams at the foundation level. So you navigate to the story 1. Right, so at this story 1 you will navigate to the foundation level. The foundation level is this level, as you can see. Okay, so we are to be having a beams, all right, at this provision successfully. So you click on the beam right there. Okay, so after which the beam sections is going to be 250 by 450, just like this. So you select that, 250 by 450, just like this. Okay, so we'll come to the 3D. So we'll be taking this beam upward. All right, we'll be taking this beam upward. We're taking this beam upward to be, we'll take it upward, we'll take it upward 350. So you type 350 there, pick the first point and pick the second point. You have the beam just like this. Okay, but we want it to be in line with the story. We want to be in line with the story 0. Okay, with the green line on the story 0. So you have to increase this now to let's take 400. Update that. It's not in line. Also we take it as 500. Update that. Okay, so we got it there. After which we will continue to place this successfully, but we can place all at once. Okay, how do we do that? You select that command, navigate to the plan view. You get it on the plan view just like this. Pick any point out there, hold the left mouse button and do a sheet over all of these provisions to have all the beams inserted just like this. After which you can navigate to the 3D. So you have this successfully inserted, and then straight away you'll be inserting the slab also at this level. All right, so for us to insert the slab successfully, click on the slab right there. We'll be using the slab thickness of 150. Okay, 150, or we'll take it to be 200. Come to the loadings, and so we are to be considering the additional dead load of 2 kilonewton. For the live load, we navigate to parking for cars and light van, and then we use that imposed load successfully. You place the slab. Now the slab will go to the foundation. So we will subtract, if you subtract 900 the depth of the foundation from the thickness of the slab, you will be having 700, right? So 700, you have to now navigate to the general tab right there, where you have okay, go back to the loads, where you have these relative levels. You put 700 right there. Click here to insert the slab right in line with the beams, right, just like this. So we'll continue to place the slab successfully. All right, place the slab just like this, okay, just like this. All right, okay, after the instruction is successful, just like this, close this dialog. All right, now the steel beams. The steel beam is inclined to an height of 2.5 meter. Okay, so we will be defining that successfully. Navigate to the story 2. For us to insert the steel beams successfully, what we need to do is we have to select the steel beams right away, and then come to the section manager, and then we'll go straight away, select UB, universal beam, and then we'll be having this one used 127 76 13 right away. Select it, click on the OK options. So we are extending it from this point up to this point. So we pick the first point, and then you pick the second point of the beam. So you have it like this. This is how you will have it to be, just like this. Okay, for the angle or the height of inclinations, what we just need to do, you just have to come to this position where you have a 3D, and then you will incline this first point to 2500. Click on update, just like this. Okay, so deselect this command, and then you have to continue to place that successfully, just like this. Okay, and then deselect this, get that. All right, just like this. All right, so after placing this successfully, one thing you can do also, you can mirror this to this other side. I don't know, you want to use mirror in Protastructure, just have to close this dialog first. Want to use mirror in Protastructure, you have to select the object first, select the object first. After you get the object, select right click, and then you see mirror. You select the mirror, and then you pick the reference point. I will use this grid line 2 as my reference point, so I'll pick that. Click on OK. Click on OK. See, you have this mirror in this way. All right, but I really want it to mirror this way. I want it to mirror either way side. Okay, but that will require some settings. All right, so for that reason we will continue to place this manually. Okay, so we'll also have it this other way around, and we'll have it also this other way around. You click on this beam set out. Okay, in the property, we still consider this property of the beam. You come all the way to this provision. This time around we will be placing it this way, from this point to this point. So if you notice, it is this other side, okay, that is coming up. So we need to bring this provision to 0, and then bring this provision to 2500. Click on update. You have that. Deselect that, select it, and then continue to place it in these directions successfully, just like this. All right, after having placed this successfully, what you now need to do is we will be having a beam connecting these stanchions. Okay, so that beam will have this provision to be 0. Okay, and then we place the beam from this point to that point, just like this. Okay, you can see. All right, so having this done, we'll be having another inclined beam in these directions. Okay, so for you to do that, you have to make these provisions to be 2500, and after which you will pick the first point, and then pick the second point to have that. Right, just like this. Okay, so having that instructed successfully, what we need to do now is we change these provisions to 0. Okay, and then we'll pick the first point and the last point to have a beam that connected the stanchion successfully, just like this. The next thing we'll be considering, we are going to be placing a truss at these provisions. Then this particular angle is going to rest on the truss successfully. So how do we do that? We are going to close this dialog first, after which navigate to where you have a truss. Pick the first point of the truss, all the way pick the second point of the truss. Alright, so in the truss dialog we are going to be considering this type of truss. Okay, so we'll come to the members. In the member setting, we may not necessarily use a universal angle. Alright, so for the top cut we'll be considering a square hollow sections, this one. Okay, for this square hollow sections we may be considering 120 by 8. Alright, a square hollow sections, so you select that. Okay, then for the bottom cut, the same square hollow sections, 120 by 8. Select that. Select OK options again. For the diagonal, we'll be having also a square hollow sections. This time around we'll be using 700 by 5. Click on it, OK. Then for the verticals, a square hollow sections to this one, 700 by 5. Just like this. Okay, so after having that selected successfully, we'll come to this provision, the geometry, and then we will be able to the numbers of spacing we are having. We will consider 15 of this. All right, and then we will check and then be able to use this type of truss. This one, turn it to change that provisions numbers of space to 15. So we are having 1.5 1.9 spacing, that is too much, and then we will consider 19 1.5 for 19. Okay, let's just use 20 numbers of space just like this. Okay, after having that set successfully, the next thing we will consider is the apex height. The apex height, we are going to be using 2300, just like this, okay. Then we will not have any cantilever, there will be no cantilever. All right, so after which the truss support placement, you see, is a bottom. Okay, it's a bottom chord, so we just have to click on the OK. So once you click on OK, you deselect this command and you have this, just like this. Okay, so having said this, we are going to be setting the polines successfully. So for the polines, you have just to click on the polines right there, select the first beam and the second beam to have the polines just like this. Okay, so for the poline spacing is 100. This can be adjusted depending on what you want. All right, and so if you want to be having a cantilever, right, you can take it to be 1 meter, just like this. Cantilever left, also 1 meter. All right, after which you will have to just click on OK options to insert polines, just like this. So with the same setting, we have to insert polines in this particular provisions. Select this and that, get the poline selected again, this one, pick the first one, pick the second one, click on OK. All right, pick the first one and the last one, get the poline selected again, pick the first and the last one. OK options. All right, so here is the commercial car park. All right, we have designed this successfully, just like this. We have modeled this successfully. All right, if you have any question, you can drop it at the comment sections. I'll be glad to attend to your questions. Don't forget to like the lesson, subscribe if you have not subscribed to this channel. All right, in the next lesson, we will look at the analysis and design of this commercial car park successfully. We design the steel members, we design the polines, all the structural elements. Okay, for the slab, we'll be using the finite element method to carry out the design successfully. So stay tuned and stay connected. In this presentation, we are going to be loading this structure. After loading the structure, we will analyze the structure and design as well as the foundations design. So we'll be covering this in this lesson. And so once again, you are welcome. This is a continuation lesson of the previous one we did on this commercial car park. And so I will want you to like the lesson, subscribe to this channel, and stay tuned for my advanced lesson. Let's get into the lessons. So at first, we will be loading this structure. So we will navigate to the analysis tab, click on the building analysis. So in this building analysis, we go to the parameters. In the parameter, these are all the loads template we used for the foundations. The foundations allowable stress. The soil allowable stress, we are going to be considering 100. Soil allowable stress 100 kilo Newton per square meter, like this. And then you can come to the title and put the title of the project right away. Then click OK. Then for the loads, we will be activating loading combinations. Click on loading generator. We will not have an horizontal load because it's not an high-rise structure. Okay, so click on OK to activate that successfully, just like this. Click on OK. Okay. Then we have to set the reinforced concrete material. So click on the edit for the foundations. We will be using the strength of the concrete 20/25. All right, and then click on OK. The foundations rebars, we have to check 12 and 16. Then uncheck the rest. So we are considering these two. Okay, click on OK. All right, so I will go to the default. We have columns in the structure. So for the strength, we are going to use this. Apply it to all. Click on OK. And then for the steel strength, we use 16. For 60, apply it to all. OK. And then the diameter of the columns, we will use 16 and 20 and 25. Then just have to select the rest, just like this, click on OK. Options. Then for the beams, we do the same thing. We are going to use 16, 20 and 25. Okay. Right, for the links, we will use 8 and 10. Okay, just like this, click on OK. So after which you just have to, we have okay, so for the slab, let's check for that. For the slab, we will use 12 and 10, 12 and 10 for the slabs. Okay, just like this. So click on OK. So with our wall in this project, so click on OK options. After which you have to close this dialog and then you save this project. After you get this project saved, we will navigate to settings and also do some settings on the reinforced concrete columns. We will go to rebar longitudinal bars and then we'll be able to select the maximum right there, and then go to links. The links is choosing as T8, so this is maximum minimum selected. Click on OK options. Go back again and be able to check it out for the story beams on foundations beams. These beams you've seen here is a split beam as is taken as the foundation beam. Okay, so click on settings right there. So come to parameters and then you can be able to select the maximum bars right there. Maximum. Okay, then for the other ones are okay. All right, you can check this provision, click on save. Okay, so you go back again and then check your story beam. Make sure that the maximum bars is selected. The maximum bar should be selected. Okay, everything is all right here. Click on save. After which we'll go back to the settings again, the foundations settings. We may provide here 12. Okay, just like this. Then the default footing depth is 450. We may take this to be 350. Sorry, that's 320, 350. Just like this. Okay, so after all of these necessary settings, you just click on OK. Alright, and save the project. After getting the project saved, we'll be applying some load on these polines. Okay, so you just have to select the poline, right click, and then click on the property. So in this property, navigate to load options and then add a load. So for this is for G load, have it to be 0.1. Then select this provision as select all and then apply it to all of that polines. You navigate to the Q load, which is the live load. Okay, have that load to be 2 in this provision, 0.2, and then in this provisions you just have to click and then be able to add it to the polines just like this. So click on OK. So this polines now is loaded now. Okay, then these other ones you will do the same thing. All right, for the sake of time, I have done that. Okay, so now the project is set for analysis. Save this project. The project is set for analysis. Now we go to the analysis tab and then the building analysis. So in these provisions, it goes straight away to analysis, and then you check the project if there will be any error in this project. So we are having number of error to be 0, so we are safe, and then we cannot move to analysis. Ask the program to design the columns, design the beams, and as well check the steel members successfully. So click on start. So building analysis is completed successfully. So click on OK, and then you can go to post analysis. So model and analysis display. You want to check that, fine. But I would like us to close this dialog. So you can now start to check your members, whether they have passed design or they have failed. It's the stations. Select it right there, and then you will navigate to steel member design. So this is it. It's been designed successfully. check for combined forces, Asia compression check, and shear check everything as past design. Click on OK. For the steel purlins, you also do some checklist. Okay, so you can see everything as past design, the purlins. All right, so check the beam. So nothing is wrong. Okay, check for combined forces and axial compression check as passed that beam. All right, so for the columns, we look at the columns sections, and the sections I was selected for the design. All right, so click on interactive device 8T16. Okay, selected for that columns. Okay, the column section might use 350 by 350. Click on OK, just like this. Okay, so everything has been designed here. Okay, so what we do is we are going to be designing the beam and the slab. So because if you check this beam now and then you check the sections of this beam sections, right, so if you come to these provisions, because the beam is at level 1, it's at level 1, sorry, it's at story 0. Okay, just like this. So if you expand this beam is more or less like a splint beam, just like this. Click on this and then check the active story beams. So you see the beams are not designed. Right, so the same thing applicable to the slab. If we navigate to the plan view, just like this, and you try to draw strips here for this slab. So if I should choose my direction, x direction, analytical strips, and I try to draw it right away, you will notice that the reinforcement is not generating. This tells you that this level you cannot use analytical strips. Okay, rather you are going to be considering finite element. Okay, so we will run a finite element analysis, okay, of this floor. So let's start to do that right away. So we'll go to the strips right there, and then we'll choose FA strips. Okay, and then we are in the direction X. Come to this provision, still this first one, this one. All right, so after which we are in direction X, and then just draw the FA strips right away, just like this. So we go to the Y directions and change that to 1. Okay, and then it starts to draw it just the same way. This is in the Y directions. Okay, alright, so after I must have done with this, just like this, what you just need to do is close this dialog and save this project. So after I get this project saved, you will just have to come to these provisions, building analysis, and then you are using this to design this one because it's on the soil. You have to design it as a raft. Okay, so you have to just select this. Alright, you can use the subgrade reactions and include column sections as well. Click on foundations, foundation mesh and analysis. So here we go. So we have to design this successfully. So this is the plate size and as well as the uniformity factors. We use 100%. Sorry, 100%, and then we click on generate model. So we have the model generated just the way it is calculated, calculating the plates for the raft analysis. So the plate model is being generated just like this. Click on this close button. So this will transfer us to the post analysis processing and report. Alright, so in the post analysis processing and report, we will click on the analysis post processing. So in the analysis processing, we will have this. So what we just need to do right away, you can also check the animations of this based on the load, although the load is not that much on the structure. Okay, because it's just a simple car park. Alright, so you just have to stop that and click on the standard contour when you to get the standard contour done, you can now start to check the movement in the global local axis and the torsional movement, just like this. Alright, and then you can check your movement in the local axis M1, M2, and M12. You just have to click on that. So after which you check the movement using wood and hammer. Then you can now check the required steel area. So if you check here, you'll be seeing the steel area in this key right here, this one. Alright, for this where we are, this is the area of steel top one. So you can see it's here. Area of steel top one is there. Click on the highest. You can see from the highest to the lowest area of steel values. Then also soil pressure, you click on that to check, because it is assumed that the slab is right on top of the soil. So you have to check if this is actually okay. Alright, everything is okay. On the soil threshold, the limit of pressure, also have to check if it is okay. So everything is okay. After which we can have edit user defined contour for the rebars, but we wouldn't want to do that because the strips we draw will generate rebars for us automatically. So click on this close button. So you are asked to transfer slab strips FA analysis results. Click on OK options, and this will take some few minutes to transfer it successfully. So the transfer is done successfully. Now you just have to click on transfer foundation beam results. So we click here to get the foundation beam finite element result, transfer successfully. After which you close this dialog. So here we are. So we just have to, what you need to come to these provisions where you have arrange steel bars. So once you click in this drop down menu and you select update steel bars, you see steel bars will be generated for all of these slabs successfully. So we click there. Alright, so you can see the steel bar is generated now. This is top bar, white 10. Okay, and then you see the bottom bar also white 10. Alright, just like this. So this is how we generate rebars for this particular provisions successfully. Okay, so after which we now have to check the beams again. So select the beams, right click, and then set beams active story. You have this. So now you have to carry out beam design batch mode, and then select all bars and calculate. So you close that. You can see the euro shade is being generated, but the beams is still having a failure sign. So that is not an issue. You have to check the beams one by one by interacting it. So you see what is happening here. Okay, we are having some. This is showing that the section is insufficient. Okay, you see the sections of the beams is not sufficient enough. Section insufficient. So what we just need to do in this case is we can just come to these provisions. In this provision, I can be able to increase the sections of these beams successfully and then get them designed as well. Check here. We are also having the same stuff right there. So at first, to resolve this, you just have like this one now as past a design, because I know that the yield ratio is very small and nothing is actually happening to the beam. The yield ratio is okay. The beam is 250 by 450, not bad. Okay, but the sections of this stirrups seems to be not okay. But by the time you update it, you see that all the beams has actually passed design successfully. So you close this right away, and then you will just have to save the project for the foundation design. For the foundation design, we'll navigate to the 3D just like this, and then we'll get all these foundations selected successfully so that we can insert the part footings. Get all the foundation like this, get them selected, and then check all is selected successfully. So you right click and then insert part footings, create typical footings for the selected columns. Yes, I want it to be typical. Click on OK, and then be able to select. Okay, this is using white. There's no white dwarf here. Use 16, and then 16. Click on calculate. We have to square this. So we are having 1.9 by 1.9 footing. This is quite high. Alright. Click on OK. And then OK again. And this is how we insert our footings. Just like this. Okay. So we are done with the analysis of this structure. We have also designed it, and as well as the foundation design and the slab design. Okay, in the next lesson we will be taking this to Protastructure and see how we will design the steel we'll see how we design the steel base plates, and as well as the purlin connections and these beams connections. Okay, so stay tuned, stay connected, subscribe, like the lesson, and I'll see you in the next lesson. In this presentation, we are going to be exporting or taking this commercial car park structure to Protastructure so we can design the steel connections successfully. Once again, you are welcome to these presentations. This is CAD levels 100. I want to urge you to hit on the red subscribe button, subscribe to this channel, like this lesson as well. Straight away, let us go into the lesson. Alright, in the previous lesson, this project was actually analyzed successfully. If I should select one of these member, right click, and then I select the steel member design, you will notice that all the check has passed test. Alright, the utilization ratio, the axial compressions check, the shear check, the tension, and all of that has been checked successfully. So we will be designing the connections successfully. And for us to do this, you have to just navigate to this steel connection, this provision, select load Protastructure, select right there. This will automatically launch Protastructure 2018 successfully, and it will get the project into the program. Okay, so click on this to close these provisions. So this is the structure right in Protastructure. So at first, I will be showing you how to design your connections, like the purlin connections, like the orange connection, the fin plate connections as well. So we will be using these provisions. Okay, for the purlin connections, you will use this. You have to first of all right click on it, and then it dialog will come up just like this. Once the dialog come up, these are different support type of connections to purlins. All right, so you can select any one here. You choose this one, angle type, and then select revert clips. Okay, and then you click on get and apply. Okay, all right, so after which you just have to left click on the connections right there. Once you left click on it, you select the member, the primary member, and then the secondary member. You right click to insert that connection successfully. All right, so here it is. This is the connection inserted successfully. The same thing applicable, the primary and secondary, right click to insert that just like this. Primary and secondary members, right click, okay, just like this. So this is how we insert purlin connections just at ease while using Protastructure successfully. It's a very effective programs in terms of connection design, okay, of steel members. All right, just like this. Okay, so for the orange connection, we'll be using on connection. So I will have to interrupt this. I have to right click to interrupt that command. Okay, after which we'll go straight away to the orange connection. This one, the orange, you have just to click on that. So once you click on it, you select the primary and the secondary to insert the orange. You can see, all right, primary and the secondary to insert the orange there. Okay, so you interrupt to deselect that command. I will have to rotate this so you see it very well, just like this. Okay, these are the macros. These are the macros. If you want to remove these macros, what you need to do, you just have to come to this provisions, this place where you have macros visibility. You click on it, it will be turned off. All right, just like this. And then if you want to remove this auxiliary files, this one, okay, the cut shaded portions, you remove it right there. Okay, just like this. So you have something of this kind. If I should select this, I select this because I want to rotate this or orbit this around within the stanchion. Okay, just like this. All right, so I want to be seeing this other side, this member that is coming in, this one. So I want to be connecting this beam member to the column. So I will be using thin plate connection, this one. Okay, this is thin plate connection. So I will select that and then click the primary member, the secondary member. Give it some time. All right, you wait for some time for it to connect. It actually takes time to boot. It has connected just like this. Okay, so I will interrupt this, select this stanchion so I can orbit around it. Okay, so we have successfully designed this. Okay, this is how you can carry out your polarized design successfully, as well as the orange connections and the thin plate connections successfully. If I should continue to place the polarized right away, you just pick on the polarized. Okay, you select the primary, the secondary, and then you right click to place that primary, secondary, you right click to place that. Right, just like this, just like this. Okay, just like that. So in this provision where the two polylines comes to meet together, what you just need to do is select the first one, which is the primary, the two secondary profile to insert this just like this. Okay, so just like this, first, second, and third to insert that. First, second, and third to insert that. First, second, and third to insert that. Okay, first, second, and third to insert that. First, second, and third, just like this. So this is what you're going to do to be able to insert all of your polarized connections. This is not the only connection type, there are other connection type, but I prefer using this one. That is why I am using it to demonstrate how to do this successfully in this lesson. So I will right click and then interrupt that. For the orange connection in this particular beam to columns connections, this one you can also proceed to the orange connections. Select this one, select that to insert that on connections, select the columns again, and then the beam to insert it that way. All right, so after which you have to also connect using the thin plate connections this beam to columns. Okay, so what you did, you just have to interrupt that and then use your thin plate connection, this one, pick the column which is the primary and the secondary. Okay, then right click on the mouse to activate that. Once you right click, you have to give it some minutes to be able to calculate the connections design successfully. Okay, so after the calculations is done, the connection will be created just like this. You can see. All right, I will have to interrupt this. Okay, and then move it this way so you can be able to see the connection just like this. Okay, this is the thin plate connections. Okay, all right, so this is what you will do to be able to connect all of this beam successfully just like this. Okay, so in the next lesson we will be considering how we can also connect these provisions. You see here, we are going to have a plate here, so we'll be moving this beam. We'll be moving this beam towards the negative directions of the vertical axis, meaning downward a little bit, so we can have a provision up here where we can have a plate. So this truss is going to sit on the plate and it will be welded to the plate. So that is the construction fabrications we'll be looking at in the next lesson, and also the anchor bolt, the plates as well as the bolt will be, producing it on our own. We might not necessarily use that of the Protastructure, but we'll be doing it on our own successfully, just like that. Okay, so this brings us to the end of this lesson. You just have to continue to place your polylines as well as the orange and then thin plate connections, okay, successfully, as we continue in the next lesson. Once again, don't forget to like the lesson. Don't forget to also subscribe for more advanced lesson of this kind. This is CAD level. Once again, you are welcome. Stay safe and bye for now.